Hello, we'll start presentation with the theme of painting and paint replacement automation system in the spindle. I'm OungSub Kim, the author of this study. I'm majoring in smart factory convergence at Sungyungan University in Republic of Korea. The plans are a brief introduction and related works. Next. The subject of this study is explained. Next, I will introduce the experimental environment and evaluation, and last, the conclusion. A smart factory is an intelligent factory that applies ICT technology to all production processes from product planning to sales to maximize operational efficiencies. Smart factory realizes productivity improvement, quality improvement, and cost reduction, and produce customized products. The painting process is a typical 3D environment. 3D means dirty, dangerous, difficult. And since most of the paints used in the process are toxic products, so it is impossible to replace human resources and highly dependent on technician because it is fatal to the human body, and the spraying and processing of paints depend on the skilled technicians. We studied how to drive the spray trajectory and control the amount of paint and applying autocolor change to realize optimal painting quality using a robot. Through our study, production speed increased and painting automation at the level required in actual manufacturing sites are possible. And the research results will be used as important data to improve process efficiency and product quality. Driving the optimal spray trajectory in the painting process is very important because the painting thickness of a product has a very important effect on quality. Traditional method has to rely on the know-how of technicians. To drive the spray trajectory, various variables such as the position, direction, and speed of the spray gun must be considered. To optimize the spray gun according to the product is 3D scanned to drive X and Y values. The production speed and distance between products are drive to optimize the painting process. And the equation for driving the spray trajectory is described here. The paint thickness is related to the paint gun velocity and the overall distance. Overall distance. Left-hand side means the paint thickness of the flame. X the distance to the gun center. D the overall distance. V the gun velocity. This is function of x and b. To find an optimal velocity v and overall distance d, the mean square error of the thickness deviation from the required thickness must be minimized, and we can get this first equation. And the maximum pane thickness and minimum pane thickness have to be optimized because they will determine the pane thickness deviation from the average pane thickness, and we can get this second equation. Finally, we can get this equation using first and second equation. Auto spray painting can automate paint by using compressed air as an energy source, and it is possible to paint by adjusting the viscosity of paint in various patterns, various patterns and a wide range. When using auto spray gun, the painting should be done considering the number of overlaps according to the shape of the pattern. In general, circular patterns should be painted with 1/2 overlap. Oval patterns with 1/3 overlap, and rectangular pattern with 1/4 overlap. In addition, the viscosity of the paint generally uses 13 to 6 seconds in primer coating and 20 to 30 seconds in top coating. Since the viscosity of the painting is very sensitive to temperature and humidity, the viscosity of the paint must be kept constant through controlled temperature and humidity. This is painting automation process. Painting is filled in the gun body, and the filled paint incorporated by a trigger signal from the robot to make a pattern of certain size and color the surface to be painted. When the air pressing the needle is discharged through the cylinder by the trigger signal, the needle and saddle are brought into close contact with each other by the pressure at the lower end of the needle, and the spray is sprayed. A spraying color change is a device for controlling the flow of painting in two directions. It is operated by a slow valve. If the paint is stagnant for a long time, mottling occurs due to hardening, and pigment precipitation. In order to prevent hardening and mottling due to pigment precipitation, it is necessary to maintain the fluidity of the paint through continuous circulation or discharge. We propose a painting process automation system using a robot. In order to achieve optimal painting quality, we drive the spraying trajectory controls the amount of paint applied auto spray and auto color change. We satisfy the production speed required by the manufacturing site. This is specification of the robot and the main parts used in the system. This is concept design of painting process automation robot. For the painting of fast-moving products on the spindle line, ace sprays guns and color change cartridges capable of driving each X and Y axis can realize optimal product painting. It moves quickly from the bottom to top or vertical painting. We drive the optimal spraying trajectory based on three dimensions and implement on an automation process that produces quality products. This is auto spray gun and three-way color change cartridge. Auto spray gun and three-way color change move up and down using minimum paint through spray trajectory optimized for each product, overlapping paint to maintain a constant painting thickness of the product. It is also important to constant temperature and humidity for the best condition of paint. Through these studies, we will able to implement a painting automation system that can be used in a real manufacturing environment. Our painting automation system replaced the manual color change and cartridge cleaning by the operator. We reduced the time required for color change from 2 hours to 50 minutes. The company on experiment was conducted with manufacturing companies in Republic of Korea. The company mainly produces cosmetic cases, and due to its complex shape and small size, it has been painted only by hand. We tested the painting process automation system using robots by constructing robots in the cosmetic case painting line. These are examples of products produced on the line on which we have implemented systems. This is a production line process for painting using a spindle line. The experimental conditions are as follows. Existing spraying speed is 3 meters per minute and product thickness is 75 millimeter millimeter. Production is 159.6 each per minute. And existing color change time is 20 minutes. This is painting process after implementing the robot system. The experiment compared with the status of the painting process described above. We compare the production volume and defect rate before and after implementing the painting robot. This is comparison of the key performance indicators before and after implementing the robot system. Production increased by 15.9% and effective rate decreased by 37.5%. We proposed painting and paint replacement automation system in spindle line. The spring trajectory was optimized. The amount of paint was controlled and auto change was applied to realize an efficient production environment. Through the proposed system, we implement an automation system that can satisfy production speed and quality in a real manufacturing environment. This research result will be used as important data to improve process efficiency and product quality. Thank you.